Well, he's a smoker.
Okay, so after 1 hour then.
Break before Adnan.
Then he need a break before Adnan. Okay.
So we need a break before Adnan
One
does.
of it. You're the guest of Devoteam in The Hague at the moment, and we're a great company to work for, I think. We do lots of stuff, and we also make mistakes. So apparently we thought, let's make, what's the word in English for sticker? It's sticker, right? Yeah? Self-adhesive component. These were intended to be at the size of 6 by 6 centimeters. But you're still free to take one if you need. They will fit snugly to the windshield of your car. But only do that if you're not looking for a new job. But seriously, if you want one, take one. And we also have these stickers. I love container dreams. Yeah, you can take those as well. But enough of that foolishness. A couple of weeks ago, Gopal, Stephan and Adnan suggested to do a hands-on workshop while presentation type thingy about Kubernetes. Kubernetes 101. And that's exactly what we're going to do. And I'm really happy that you guys volunteered to do this. And well, I trust it's going to be very interesting. And if not, we still have the material and we can redo it again. So thank you very much. Stephan, you're going to kick off?
Yes, I'm going to kick off.
Excellent. Thanks.
All right. So welcome to this introduction to Kubernetes and OpenShift. This is the agenda. First, I'm going to do the first part, a half hour, just introduction to Kubernetes. What is it? What's a container? Why you need orchestration? Just the topology of Kubernetes. Then the second part is a little bit more in depth. It's getting your feet wet in Kubernetes is going to be done by Gopal. And after that, we go in deep dive into Kubernetes with OpenShift, which is going to be held by Adnan. After that, if we still have some time, we will reserve some time for questions. But if it's a really 101, so if some of the terminology is not known, please let me know, and we'll try to explain during the session as well. Okay, so I kind of stole this slide from Adnan, which is...
I stole it from Red Hat. And they stole it from someone else.
Most likely. So this is the IT must evolve to stay ahead of the demands. So what is this? It shows where we're coming from. So for example, the development process, we started with waterfall. After that, we went to an agile way of working, and now we're in the time of DevOps. Same for application infrastructure on this side. We started with data centers, we went to hosted, and now we are at cloud. For application architecture, we went from monolithic architectures. Then we moved to multiple tiers architectures, and we're now at microservices. And for the deployment and packaging, we started with physical servers, then we went to virtual servers, and now we're in the time of containers. Everything needs to be in a container these days. So this is like a well-known flow for where we are. So if we look at what is a container, it's very similar to a virtual machine. However, there are some differences. There is no need for a guest operating system. So you have the bare metal. It has an operating system, but not all the VMs. So in the old world, you have VMs that have their own operating system. So that's a lot of overhead. Containers don't have that kind of stuff. It's fully self-contained application with all the dependencies. So that means that everything what's needed for the container is also inside the container. So that means it's highly portable. So you can run it everywhere. So you can start developing on your local machine, and then put the same container on-premise or even in the cloud, and it will work the same as you intended on your laptop. So that's actually pretty fun. So this is the overview of that. So you see on the left-hand side, you still have the host hardware similar on the container one, host operating system on top of that. Then you got for virtual machines, you got a hypervisor, and for containers you have a Docker engine. It's pretty much doing the same. It's hosting the virtual machines or the containers. And then on the left side, you see that you have a guest OS with on top of that your app. And for containers you don't, you only have the apps. That means it's the same hardware, can most likely run multiple apps more than in case of VMs. So, with containers, there's a lot of, we need some kind of system that could manage your containers. You need to launch them on the underlying machines. You want to make sure that they are distributed. There's something like that they remain healthy, so you need something like a health check or something like that. This can be achieved by a container orchestration system. One of those is Kubernetes, and you can do that, but even more. So let's dive into Kubernetes. This is a simple Kubernetes cluster. So every Kubernetes cluster consists of a master, which is the control plane. It actually controls all the nodes so running in your cluster. A node is like a worker machine. I'm going to that in a few minutes. And the node also contains some node processes just to make sure that they're up, that they are listening to the API server, for example, but also to make sure that you can contact them from outside, so like a proxy something.
But in the container, you use the operating system of the underlying host.
In the container, so in the container, inside the node, you have pods, but we'll go to that in a moment. But in the pods, you deploy your containers. So a node is just actually a worker machine. So that means that compared to your VM, it's more likely, it's your virtual machine. So it's
okay.
It doesn't load the whole operating.
No, but if
it doesn't need an operating
I was
system.
thinking about the previous slide, like you said there's no OS in the container.
In the container there's not. So this Kubernetes cluster is running on an operating system, of course. You have some bare metal or virtual machine, and you install Kubernetes, that's your cluster. That's just of course running on an OS.
Well, what takes care of the operating system function in the container then?
The dependencies all inside your container itself. So you need to make sure that the libraries are there and all that kind of stuff. But that's actually for the developer to make sure that this application is running. So you need to know for your application to run, I need this library, I need this binary, and then you need to put all those together inside your container. That's something that you need to be taken care of as a developer yourself. It's not the cluster.
So it will not package the whole operating system, it will just take the parts of the kernel that's needed for execution. So that way it's much easier or faster to load and this kind of thing.
But I know that the Linux container creates symbolic links to the underlying operating system. Does Docker do that also? Is it
Not by
different?
It's not by default, you need to do that yourself.
So you mean, does it mount a file system from the local host or?
For Linux containers, I think it does. It creates
VM.
symbolic links to the same files, but then on the host.
No, that's not by default.
So this is actually container 101 we're discussing, but it's like containers are actually isolated processes within the host OS. So they are actually a group of processes isolated from each other within the host OS.
Okay, so to explain your question. Okay. So this is the topology of the cluster. So you have the nodes, which is the actual worker machine. Go more in depth and explain that in a bit. Pods, which is actually just a group of containers. It can be one container, it can be multiple containers, but you name them as a pod. I will explain that more in depth as well. You have labels, which is just a key value pair which you can attach to an object. So that means, for example, your version dev and tier is going to be front end. So that's just the way you label it, so that you know how you can. With selectors, you can select them. So that means that you use queries to get all the, for example, environment equals production. Then get all the containers with the labels production. Services, which is provides a reliable network endpoint based on labels. So that means that you can do like small load balancing out of default. I will show that in a bit as well. You got replica sets, so that's explicit definition of how many desired states you want. So for example, I want 2 front-end servers. With replica sets, you can just put it on 2, and then automatically Kubernetes will create 2 pods. Deployments that's built on top of replica sets. That means it's a nice method to do version control. yeah, you can make rollbacks, for example, pretty simple. Namespaces, resources can be put in a namespace. By default, you only have one namespace, but there are cases where you can use more. You can partition them in separate namespaces. And then you also have jobs, which is actually mostly used for performing batch operations. So that's small living pods that you start up, do your batch processing, and then it will be killed again. And then there is a lot more. You got volume, stateful, sets, ingress, annotation, daemon sets, network policies, security contact, service account, and custom, and even more than that. We're not going to in depth on this one, but just to show you the topology of the cluster is pretty well spread. There's a lot to find and a lot that you can handle with Kubernetes.
You mentioned jobs as in batch processing. Is that
Yes.
mainly used for managing containers and the pods or stuff
No,
like
it's
that?
just for batch processing. So if you have like a script that needs to run somewhere for a while and then it can be closed again, then you can use jobs just to spin up a container, run your batch, and kill the pod again. So that means that it was short-lived. Okay, so a node. A node is a worker machine, so as it tells, it's just the actual, it can be running on a VM or a physical machine. A node can host one or multiple pods, and a node is consisted of a container runtime, a kubelet, and a kubelet. A kubelet is actually the agent. It talks to the master, so it gets via the API server, it gets his jobs and tasks. And the container runtime works with the kubelet for managing stuff for the containers itself. So starting and stopping the containers, but also putting the images from the internet over to repository online. Yes?
Quick question, is pod another name for containers?
It's a group of containers. So it can be one container, but it can also be multiple containers. But yeah, at the end it's just a container. And kubeprox that is responsible for the brains of the IP, so that makes sure that's a sort of kind of load balancing and for a unique IP, so that every pod has its own unique IP. That's a little bit in a nutshell the node. This is how it looks. So a node has multiple pods inside, and inside the pod you have the containerized apps. And below, I don't know if it's readable at the end, but you have the kubelet and the Docker processes. So the Docker engine is actually let me see, what's the Docker? It's the kubelet and the second part. So you have the proxy, the kubelet, and the engine. Docker, yes, the Docker.
Container engine.
Yeah. Okay, so that's
Simple way is the
yeah, exactly. So that's responsible for communicating with the engine. And then you can stuff like volume, which can be like a database or whatever you just put inside your pod. It's needed for the container to run.
Sorry, is a pod, is that just for a single node or can it be distributed over multiple nodes?
One per
one.
Per
So
node, okay.
on one node, so look at this, so you have the node as a server,
Yeah.
which you have your Linux and Docker running. Then on that node you divide it with the pods, which is then smallest manageable unit by Kubernetes. So the pod will have the IP address, and if you want to scale, you will scale the pods.
Okay.
But then in one pod you can combine multiple containers. It can be one-on-one, so that's the easiest way when you deploy one container in the pod and then you scale the pods and you get that elasticity. But if you want to break your code in multiple components, which it's basically made of multiple containers, you will deploy them into one pod, and then scaling with pod, you will replicate all the things that are in that pod. So you cannot scale the containers inside one pod.
Okay.
So the rule of thumb is to keep it as small as possible, so to have as less as containers needed to run it. microservice. Yeah, it's a microservice. The model and desired state. We declare the desired state of our application, so your microservice, in a manifest file, which is YAML or JSON. And this is being posted to the Kubernetes API server. So that's the master. And I'm typically using kubectl command via command line interface or other tools. And the Kubernetes then stores this in the cluster store as the application desired state, so it knows what the desired state is. And then it deploys the applications into the cluster. And Kubernetes implements watch loops to make sure the cluster doesn't vary from desired state. So if it sees that the desired state, for example, I want 2 front-end servers and one front-end server is falling away, for which reason it will automatically start up a new pod with the front-end server again. So it sees that it has 2 front-end servers running. So this is actually one of the manifest files, which shows all the different kind of things that are already been mentioning. This side. So this is the differentiation. So you have kind is deployment. So this is the deployment part, and this is kind service. So it's split up in 2 pieces. Then here you have the labels. So we call this one vote. And with this selector, it's also calling vote. So that means that you can easily, in this spec, you can see the vote is here and it's also labeled here. So it means that it always knows what belongs to each other. Because if you have one big manifest file, this is just one part, but you can have like 10 or 20 of these kind of stuff, deployments and services in one file. So it's easily to find and to search. So this is the deployment part, so that's the actual, it's going to pull from the Docker image an example voting app, and it's calling for the latest version of that, and it needs to have a container port open for 80, and it's also creating a service, which I already mentioned is a load balancer in front of it, so which is external reachable also on port 80, and you can define it on this way. And here you can see the easiest way just to have, I want 5 replicas of this one. So this one will create 5 pods. I think that's, and if the restart policy is always, so that means it's going to be restarting if it's going to fail.
I assume you don't write this by hand.
You do write this by hand.
Yes.
There are tools to help.
Yeah, but it's just JSON, so everyone knows it, right?
I know what YAML is a bridge for with spaces.
Yeah, so it's intended indeed, so that means that you have 2 spaces for everything.
This is a very simple example.
This is a very simple example.
Yeah, that's
so
why I
Adnan's
said
going
you
to
don't
show a very complex one.
That's why I said you don't want to write this by hand.
Yeah, it's actually
We will come to that.
Yeah. Okay, so I mentioned pods a couple of times, so that's actually just a group of containers which is deployed and scheduled together. It's an atomic unit, so that means you don't scale the app by adding. You do so by adding or removing pods. You don't scale anything by putting anything else inside the existing container. So if you want to have 2 front ends, for example, you just spin up another pod with the same container in it, instead of that you just tweak the container that has already been running. Yeah, so that means that you just have it fast and in a similar way. Containers within one pod always share IP addresses, so that makes it easier for them to contact each other. And pods are ephemeral, which means they are mortal. They born, they die, and they live. And if they die unexpectedly, you don't going to try to fix it. You just spin up a new pod. So they can be very short term, or they can live for. That depends on the pod itself. So this is actually the one of just a simple flow of the pods. They have one IP address, so that's the 10.4. Inside you have the containerized apps, and then some volume if needed. And in this case, it's just a simple scale, because one can only have one container, or you can have one container with a volume of 2 containers. It all depends on what you want. But the rule of thumb is that you put as least in as possible, so to make your service run. So you need to take into account that. Yes.
So what happens if you have 2 containers listening on the same port, for example, and in one pod, and then if you try to access.
So there is only one entry point for your pod. So that means that you have to do the port numbering yourself. So if you have two applications inside your pod, both running on 80, I don't know what happens. I think you can just
First of all, it's not a smart decision to do that.
No, so you need to take it into account yourself. Exactly.
But then again, pod and the service will have the fixed IP address. So if you are scaling the pods, so the question maybe would be, how do I know in which pod to access the application? So you have the service which has a fixed IP address.
So
you always hit
outside.
one service, which is a separate component, like you saw on that manifest file. It was two components. So the service is separate, and it will be a static one.
Yeah.
So when you want to access any of the containers, you're always going through the service. Service will be aware how many pods are available. Is it one or many? How to access them, and he will load balance that. So it's that logic is hidden from the consumer.
The replicas apply to the pods.
Yes.
So
not to the containers in the pod.
No.
No.
So scaling is elastic scaling is done by creating more pods, not by creating more containers inside the pod.
No, exactly.
In this case, you have 5 pods.
5 replicas, yes. That means
Five
I have
replicas.
5 times the example voting app.
But they
And
will
that's
have
all
different IP addresses?
No, they. So the pods itself they have, yes. Yeah.
And the service will point to
One of those 5,
the
round
load
robin by
balance between
default.
those 5 pods.
Okay, but there's one virtual IP address.
Yeah, which you're going to share with your whatever your user is.
There will be 5
5,
pods spun up with 5 different IP addresses.
With the same port exposed.
Yeah.
And who manages those IP addresses?
The cluster
Kubernetes.
itself.
So that
It's the master node, so the control plane.
so you don't have to worry about that.
No. You're never seen it go wrong.
If we go to the next slide again, with the other one. Yeah. So the other question was these 3 containerized apps in port 4.
Yeah.
Those are
So
actual containers.
containers.
Right?
Yeah. So inside.
They have their own IP address within the iPod?
No, they all have the same IP. You can
So
reach
they-
them via
the pod is the
access point.
the pod is a single network namespace. Everything inside the pod shares the same network namespace.
They can talk
Usually
to each
you
other.
would put only one container in a pod. That's the usual practice. Sometimes you need some sidecar to, but in general, pod is a unit.
Smallest
Usually
possible.
you put 1 or 2 max.
Manageable unit by the Kubernetes. So I think that maybe the presentation that is used from the Google, they want to show that you are able to put multiple containers in a pod.
That's not a good
You
app.
never do that.
But you don't do that very often. So that usually you have this is the most common scenario when you have your container application containerized in one pod, then you scale it up and you have a service in front which will hide this complexity from the consumer. So let's hit the service loads balance it. In the cases when you say that, okay, my applications may be big, maybe I can structure it, so there are some other tools like Istio Service Mesh, there are concept of a sidecar container. In that case, you would have 2 different containers, but they actually act as one unit. So you never have different applications in one pod. So it's, if you have some exotic use cases where you want to split your application into multiple containers because it's easier to package it like that, it is possible. So that is but you would like to have it one-on-one.
But if you want to have it one-on-one, then what is the use of a pod?
So the pod is the
Why shouldn't you just talk to a container instead?
the Kubernetes is
It's the
the
orchestration.
atomic unit within
Yeah.
Kubernetes is the pod. By enclosing it within the pod, Kubernetes is able to do a lot of things. They implemented the tool in the way that it sees the pod, not the container. You
Yeah.
can even run a Docker container, but it could be also different
Some different.
type of container.
Okay, yeah.
It's a management unit.
Docker Swarm
Yeah.
works like that without pods and everything, so it's only manage the containers.
Yeah.
You had a question.
I have a question. Are the services running in pods as well?
Services?
Yeah, the service that is automatically created for each pod.
Service is just a DNS entry. So it's just pointing to one of the pods. It's a resource, but it's basically when you create a service, it's just a DNS entry in the network. It's
how,
not running
then,
anywhere.
how then it can load balance? If it's just for the innocent.
Yeah.
I think in the manifest load balancer was separated. So probably also to separate
Maybe if we come to the, if you wait with those questions till the end, we will have a live demo and then we can all show that and play with it. And,
Yeah. Okay. So are there any more questions?
That was brilliant.
No more questions.
All right. Thank God.
you see.
So Gopal is going to do the second part.
So thanks, Stephan. So I'm Gopal. I don't know if I need to do an introduction, but I work as a DevOps consultant, cloud consultant in Devoteam. So my talk is more about exploring the ecosystem. It's not really a technical talk, but it's covering the history. Let me jump into the agenda. So it's rough agenda is like we start with a bit of history of Kubernetes, and then I try to look at the landscape, the overall landscape, how the project has evolved and what's coming up in the future. And so it's really not too technical. In the end, we get a little bit technical by trying to look at a way to spin up a Kubernetes cluster if you want to try it out. So the prehistory of Kubernetes is basically starts at Google. And so if you look at containers, containers have been around for quite a long time at Google, for example. Like they use containers for running their search engines, their YouTube, the Google Cloud Platform, and that's been there in Google like more than a decade. So they've built tools to manage containers and their clusters at scale. So they built things, some tools like Borg, what you see on the left side, and Omega, and they used it to manage their own clusters. So some engineers in Google came together and say they build an open source tool, and that's how Kubernetes was born. And Kubernetes basically is an evolution of, it's not an evolution, it's a different tool, but then it carries the DNA of Borg and Omega. So it's really came out of Google, and it's basically open source project.
Cable. There was a cable.
Yeah, so looking at the timeline a bit, like I said, like Google introduced Kubernetes June 2014 and open sourced it to the community basically. And so then a lot of development happened. And 1 year later, July 2015, a lot of nice things happened. The first release, 1.0 of Kubernetes was released, the first stable release. And with this triggered a lot of community interest in Kubernetes. Really, all the big vendors like Google, Red Hat, they all jumped in to actually contribute to the project itself. Actually, I remember hearing about Kubernetes when I was at DevOps Days Amsterdam, 2015 July, and that's when this happened. And it was already a talk already back then, like buzzword. So that triggered a lot of interest. And another thing is the Cloud Native Computing Foundation, CNCF, was founded also at that time. And fast forward a bit more, and Kubernetes was adopted by the CNCF. So CNCF, I'll come to that in a bit. So CNCF adopts Kubernetes as its first hosted project. And since then, there have been a lot of releases of Kubernetes. And it's one of the really fast-paced projects. Like they have like a 100-day release cadence. So like every 3 months, you can see a new release of Kubernetes coming out. I think they are at 1.11, if I'm not wrong. By the way, you can interrupt with questions if you. So, what is the Cloud Native Computing Foundation, or the CNCF? Basically, like I said, it was founded in July 2015. It's a spin-off from the Linux Foundation, so it is actually a member of the Linux Foundation. And they actually, their goal is to build a set of open source projects, bring them together to promote the growth of cloud native ecosystem. So that's they want to do this for the basically it's like a foundation to bring together these projects and then foster them and move forward with the cloud native. And it's community driven, so it's all open source community driven foundation, just like the Linux Foundation. And it's vendor neutral, so there's no like vendor thing involved. But then all the big vendors are actually involved in contributing to these projects, so it's not like, it's really this is one of the foundations which actually got a lot of vendor interest going in. So, and one of the key things is interoperability. So they bring together these open source projects, but then they try to make it interoperable. So each tool should be able to talk to each other, or we should be able to plug them in, and they are all following certain standards. And the last, but the key thing is to sustain and promote cloud native computing. So what on earth is cloud native? So it's like a buzzword, or is it like again another hype? But the thing is, it denotes a certain set of characteristics of your application. So like highly distributed, decoupled, and scalable, so really small units which are easily horizontally scalable, just like he was explaining in his talk, that the pods are really quickly scalable. So that's the way the application is built, and they're self-healing, so that you can discover their health and then quickly spin up. If something goes down, you can easily spin up a new instance. So these are the characteristics, and what are the ways to do it? One of the architectures is microservices, or you call 12-factor applications or whatnot, but that's a topology to use. And containers go really hand in hand with microservices. So that's one of the ways you can really, CNCF really comes in there to really promote the use of containers along with your microservices. So that's cloud native in like a nutshell. But
do you mean that if you call a microservice that kicks off a container, executes it, and kills it again? Is that what you mean?
So you basically run a container application. You need to run an application somewhere, and you run it in a container. So
yeah, but you say that microservices and containers go hand in glove. So does that mean that if I call a microservice, that it kicks off a container, executes it, and kills it again?
Inside the container.
So
So
the ideal place for running a microservice would be a container, because a container is not like a VM that it's not heavy, it spins up very quickly.
Doesn't need an OS or whatever.
No, but so the container stays running for the microservice. It's not that it's kicked off and killed again.
When the container comes up, the application is up. When it's down, the application is down.
Okay.
So how do we get there? So how do you get to cloud native? So the CNCF actually put a nice cloud native trail map, which I like to show you on their website. And this is their take on the whole thing. And it's like they define like a few things you need to, it's like a trail map you need to implement to get to cloud native. And it begins with like the basics are like containerization, continuous delivery, and orchestration. These are really the basics you need to have in place before you can actually implement more cloud native capabilities. And the other thing they do is they actually go and pick projects which support these these different characteristics, observability, service management. They bring these projects together, and then you have like a tool set to pick from to actually implement these things. So that's what's that? So they bring together this tool set, and what they did is they actually published it, their entire tool set on their website, and so this is
not scary.
yeah, this is not scary. So I was mixed up with the slides. So, but this an idea of how CNCF hosts projects. There are different levels of hosting, but you see that it's like a Lego blocks, right? So each individual project does one thing, and then you bring them together. So they don't do a lot, but they do one thing well, and then you have the whole tool set which you can actually put together to create your own platform, or that's also something which vendors do. So for example, if you look at OpenShift, Red Hat, actually if you look at Red Hat OpenShift, it's like a platform built from a bunch of these tools. So it has Kubernetes, it uses Fluentd, Prometheus, and a number of things to use. And Helm is like, you asked about how do you write YAML files by hand. It's pretty hard. And Helm is a tool which helps you to actually generate those YAML files. So it covers a lot of areas within. And so there's much more. And so they basically published a page on their website which looks like this. And this is like all the categories and all the projects and everything in there, and this looks horrible. So they realized that, and they actually built a tool which is a cloud-native interactive landscape, which is really a cool tool. So I want to show you. If you go to l.cncf.io, it's a page which lists all the projects in this way, and you can actually go and filter out based on different categories or whatever. Like if you want to look at, say you want to look at security or whatnot. I mean, you can filter out on different categories. So that's really a good tool. And if you go into say one specific tool, you can actually click on the card. Sorry. And then it pulls out a lot of interesting information about this project. It really pulls out like what kind of project it is, its license, the GitHub stars, the Crunchbase URL, and first commit, how many people are interested in. It's a lot of nice information you can have from this page.
Is Kubernetes a company?
Kubernetes is not. It's a project.
Yeah, but because it said 11 to 50 employees, and the headquarters was.
That means committers on GitHub.
Oh, okay.
I think they have like 2,000, 5,000 committers on GitHub, but I think that's like the core committee. So it's the CNCF has groups which foresee some projects. So it's probably the core group who drive it. But there are also companies in here, and that's like, for example, Container Solutions, Accenture, people who can support Kubernetes-based projects. And so it's a nice tool, and I actually use sometimes to like compare these tools for a customer, or it's a good place to find stuff. But anyway, moving forward, where is Kubernetes now? So this is actually from a survey taken in 2017 December. Newstack has published this, and you look at all the companies which run containers and what container management platform do they use, and clearly Kubernetes takes most of it. And this, if you look at Google Container Engine there and OpenShift, that's also running Kubernetes. So it's really kind of going towards ubiquity. And if you look at this now, probably it's even more towards Kubernetes. Anyway, so the future, the vision of CNCF it goes something roughly like this. So this is a slide I got from KubeCon, and if you look at this, like the underlying thing, the first thing is the infra layer, which is so the platform should be basically able to run on any underlying infra. It could be the cloud, it could be Google, it could be your own data center, it could be edge. It doesn't matter. Then you have a layer which is basically all the projects being built out now to support the code on the top of it. And in this layer, Kubernetes is kind of the anchor component, and you have all the CNCF projects which go together with it. And you might have local services. If you run Google, you might use some Google's own proprietary services, or if you have on your own data center, you have some database. So you have your platform there, and then you need the most important thing is actually the top one, which is your developers need to basically build stuff for your business, and they want to have a way to just run the code. So they don't want to deal with the infra, they don't want to actually deal even with containers. They just want to say, this is my code, and just run it. So that's where a lot of work is going on right now with a lot of tools in like PaaS, like OpenShift is doing, and also function as a service. And there are a lot of work going on there. So that's kind of the goal we are working towards. So it's actually a platform for building platforms. And this is a tweet from Kelsey Hightower, and this guy is quite popular in Kubernetes circles. He's one of the faces. He's a propagator. He's from working at Google. So the thing is, Kubernetes as of now is already an improvement from the existing way of deploying applications. But in the end, it's probably also going to become an abstraction layer, and you will have platforms built on top of it. So, that's where this is probably going towards. Okay, so that was a lot of theory, but we like to, if you like to get a Kubernetes cluster today and just play with it, there's a ton of options available. I listed a few of them here. Like the first one is a URL, play with Kubernetes. It's from Docker, and it's like you can go and sign up, and you get already provisioned cluster to play around with. Then you got Minikube. If you want more control, you can spin up a cluster on your laptop, a small Kubernetes cluster, and you can play around with it. But you can also use it for local development. So if you're developing on Kubernetes, you can have a local environment using Minikube. Then there's a ton of other tools listed here. But then the last three are like probably the easiest way, which is actually there are managed services by the cloud vendors. So each of the cloud vendor has its own Kubernetes service now. And this is basically a very simple way of getting a cluster. The way it works is they give you VMs and the whole control plane, the master. They are all managed by the cloud provider. You basically get the Kubernetes cluster for yourself, so you can play around with it. And my favorite way to do this is with the Google Kubernetes engine, because I think personally it's probably the best place to run Kubernetes. So I'm going to quickly show you how you can set up a Kubernetes cluster. We set up a 3-node cluster, very simple, and we use GKE, Google Kubernetes Engine. All you need to do is sign up. There is a free trial. You can put in your credit card, and you get $300 or something worth of free trial. So you can basically sign up. I already did that, so that's quite simple. I'm not going to show you how to do that.
And how fast do you burn the 300?
It's actually quite. If you're just playing around with it, they are really the prices are not that difficult. So I am running one personally for like a month now, and I just burned 40 euros.
So at the end of the day, you can
You
make
can
it a
actually, yeah.
zero cluster.
Don't forget to scale it down to zero,
Yeah,
and then
otherwise
you
it will
should
be running with a cluster of multiple machines, and that's more expensive.
So let me just.
You need a chair as well.
And that's a high chair.
I think I've got one on my plate right now. Oh. Chris, card off the balls. That's me, I guess.
Okay, so go there. So if you go to the URL and on the top there is console. Well, after you sign up, you go to the console and you see this console. What I will do is I will create a cluster. It's quite, and I will use the command line because it's cool. But you can do the same on your cluster. So it's a simple command, Google G-Cloud, so you need to have a G-Cloud client installed, which is also quite easy to do once you have your account. So G-Cloud container clusters, create, add, demo cluster, and then a few options. You need to say how many nodes you need on your cluster, version of Kubernetes, and the zone where you want to deploy. I hope it's visible. Oops. It always has to happen during the demos. Clusters.
It shows it's real.
Yes.
It's a real demo.
Sorry.
It's not the beta, yeah.
Okay, so it's going ahead and creating a cluster. It takes like roughly 2 minutes and you will have a Kubernetes cluster. But I wasn't sure if this will work, so actually provisioned a cluster up front. So while this is running, I can actually go, so yeah, okay. So in your console, you go to, on the left, Kubernetes engine, and then you're taken to this page where you see this cluster is being created, but I have already created a KISS cluster. And you see there are 3 nodes. I just run the same command with a different name, so it's the same thing. And you can drill down, look at the different details of the cluster. You basically have it, there's 3 nodes running. These are the underlying nodes which it provisioned for you, it's by itself, and the master is actually not even visible to you because it's managed by Google. Right, so that was like a basic demo. It's as simple to get a Kubernetes cluster. So
Is it possible and useful to have multiple nodes with different specifications, or is it just not?
yeah.
Yeah.
So you can have, within Google you have like a node pool concept. So you can have different node pools with different types of nodes, and then that can all be attached to the same cluster. So
Okay.
You can also, for some type of applications, define what type of nodes you would like to have.
Yeah.
And then you can also have the affinity so that this type of containers will go to this type of nodes. So you can bind that as well.
And yeah, so you can connect to this cluster, for example, running Cloud Shell. Just quickly show that as well. So if you want to do stuff with your cluster, you can go to connect, you get your Cloud Shell here, and then you can basically run your kubectl commands. Kubectl get nodes, for example, and we have result. So this way you can actually apply pods and create things. Okay. So that was basically my thing. There will be a more interesting in-depth demo next by Adnan. So I'll leave it
Thank
at
you
that.
for the pressure.
No pressure.
And final remarks, I just like to leave some tips if you want to do more learning on this. There's a really good introduction course from EDX. It's for free, so you can sign up. Kelsey Hightower, I think, is one of the people giving the training with video and also things to work on. And then CNCF has a few trainings on their website and certifications as well. We also have certified people in Devoteam. So that's something you can do. And KubeCon, that's an annual event. You can see either go or just look at the videos. There's a lot of nice material there. There are meetups happening everywhere like this one, so you can go to those. And Devoteam is a Google partner, so we actually have trainings. It's possible to get trainings and certifications from Google with these technologies. So if you're not at Devoteam, then probably join us. I think we are having So that's basically it. Come talk to us. We ask questions and probably, I don't know all the answers, these guys. But we like to talk about it. So.
Yeah. Cool.
Thanks.
Thank you. Thank you.
Roland, I don't know if you want to have a break.
Yes.
If you guys want to have a break, now is the great time to have a break.
At least one person wanted a break, so let's have a break. 7 minutes.
Everything in place. So, welcome for the third part of our presentation, deep dive into the Kubernetes and OpenShift. So, for those who don't know me, a quick intro, Adnan Drina. Now, basically what you have to take care is, I'm a senior consultant from Devoteam. Background, almost 10 years of experience in delivering large enterprise systems. Skills, technologies, services, SOA, microservices, event-driven. So how many of you are on LinkedIn? Great. Adnan Drina on LinkedIn and you will get all those information. So to the fun part. This is a very short agenda, so we wanted to have something fun for the ending of this session. So what is more fun than a demo? Live demos are always fun. So if it works, then I'm excited, you are amazed, it's fun. If it doesn't work, then you'll get to left me out while I'm sweating with my tissues. So it's fun either way. But before the demo, I also have to go with a couple of sponsored slides and explain what OpenShift is. Let's start. Beautiful slide, OpenShift. So what is OpenShift? So I wanted to try to have some kind of definitions, and then there is something happened in the past. I have a brother which is almost 10 years younger than me, and he's also now in starting of his professional IT career as a Java developer. So a month ago or a bit more, he called me as telling, okay, this new company that I'm working, they are now embracing Red Hat, and they are mentioning this new technology OpenShift. So what is? So he's a bit lazy like I am, sitting now. So instead of Googling, he calls his older brother and asking this type of question. So I explained him a very quick one. It's a platform as a service provided by Red Hat. It's a very cool solution. It runs very well on premise, like on cloud, and try it out. And that was not enough for him. So I knew also that he was very familiar with Dockers. He had some ideas of Kubernetes, so very similar, like you had a quick overview. So then I tried to explain it a bit differently. So same thing like Red Hat is doing with their most famous product Linux, where they are taking an open source technology, making it enterprise grade. They did the same thing with Docker and Kubernetes in this case. So they have taken those two technologies as the core, Docker and Kubernetes. They have added a few more open source technologies to make it a more complete platform. A few more, they claim that it's already about 30 different open source technologies, all from that cloud native foundation. And they are giving this as an enterprise-ready product with an enterprise support on which you can run your mission-critical applications. So I hope that I have give you an idea, but I would never be able to sell it like this. So let's take a marketing slide from Red Hat. So OpenShift by Red Hat, how do they see this platform? What is exactly OpenShift? So they would say the self-service. What does that mean? So with this cloud-native approach, with this platform, you are able to provision the hardware without the hassle of really going into the infra domain. So if you want to spin a database, it's almost a click on the button. If you want to spin a service, it's almost click on the button. So you get a really self-service, like you are in a shop and you click in your components that you want for building your application, and they magically appear on your console. So it's cool stuff. Multi-language, basically this is the functionality from Kubernetes. So Kubernetes offers that, so they are reselling it. Multi-language support, what does this mean? This is the mainly core of the Docker that we have now here in the core. So Docker allows you to containerize any application, build in any programming language as you put all your code and configuration in that container. So with this concept, OpenShift is also able to provide you this diversity of the languages. They call it the polyglot. Basically means that you could mix all the programming languages on the platform. So if you want to build your application, maybe you want to do some services in JavaScript, some in Java, maybe you want to try with Go. So you get that diversity. Is that really a smart thing to do in production? Yeah, that's a different question. We can discuss that later. But it's a nice selling pitch. Automation. So the guys from Red Hat have invested a lot in automation. So they are really pushing for fully automated process without any clicking or doing anything on the console. So they have the fully automated builds, deployments, all stuff, very cool. I will show you later. Collaboration. I'm pretty sure that this icon is added just to keep the symmetry between the all icons, because I have not seen any collaboration tool, neither I think it's really needed on this kind of platform, but it gives that symmetrical look and you can wrap your story around it. So,
but you have users and groups.
Yeah. Do you have? Yeah, you have users and groups. Yes. Yeah. Yes, definitely. You have also labels, which also can be.
Oh, you have a forum. That's probably a forum.
They would be able to justify this definitely. So, standard based. Okay, so this is not a joke. This is a really cool thing from Red Hat. So standards. Even when you get with the pure vanilla Kubernetes, so the open source version, there are placeholders in which you could configure the standards to which your containers need to adhere. So there are some simple rules or best practices, like you should not run your container with the root access. In plain Kubernetes, you get those placeholders empty. Guys from Red Hat have filled them all in for you with all the best practices, with all the standards, which gives you that confidence that each container that you deploy on the platform will adhere to the previously defined standards, and it will give you that enterprise-ready feeling. So cool stuff. They are investing a lot in this. Web scale, yeah, the OpenShift provides you that cloud-native platform. So aiding the nodes, scaling out, aiding the hardware is really straightforward. Cool to see. So it's capable to really scale to all the needs from the modern web applications. Open source, so yes, that is the trade model from the OpenShift. So all the technology used to build this platform are open source. So you could theoretically get them all by yourself and combine them in this kind of platform. If you have the engineers with the 200K pay slips, but if you don't, then it's better to go to the Red Hat guys, and then they do the hard job for you, and then you focus on delivering services on this platform. Enterprise grade, yes, that is the trademark, that is the price tag, that's why you are paying for this. The guys are really providing you support, guidance, they are investing in the community. What to wish more? So, cool stuff. Clear?
Yes. Yeah.
Questions?
Where can I order it?
Good. See, I'm getting better with C. But the real goal of this demo, this part is to have a live demo. So.
Spontaneous.
So we will do something like this. Maybe just to clear it out. Okay. Do you see it? No. Zoom in. Is this better? This should be better. So let's start with a simple command. OC cluster. Cool stuff. So there are multiple ways of running your local OpenShift instance. I would strongly suggest, if you are running Windows or you're not that Linux oriented, to go and try this out. OpenShift container development.
It's there.
Okay, it should be there. So there is a download page. Poof, it works. Internet works. So it will, in this case, you will be able to download a virtual machine in which you will have the pre-configured standalone version of OpenShift, which they call MiniShift. It will give you the feeling and the look of an enterprise-grade solution, but it's a virtual machine which you should use for your development purposes, and it can be persisted. So it will store the data in your VM, so when you spin it up, it will not lose, so you can develop your services constantly, which is not the case with the thing that I'm running. So I'm running an Origin version, which is an open source OpenShift. Origin, how it all started. This guy will spin not a virtual machine, but a bunch of Docker images. So maybe to see Docker registry, to store the images. There is a router which is not part of the Kubernetes. So I said Red Hat adds components on top of the Docker and Kubernetes to make it a full platform. So the router is something that you are not able to, from a public network, to access directly Kubernetes. You need something to route to it. Registry, the web console, so cool stuff. I get the opportunity to run it immediately with system admin, so I'm going to do that. Poof, and it connects. So I see some projects running. We are not keeping this all in the command line. So it says here as I'm run that I can go to the localhost 8443 port to see the command. So let's check that. It should be here already. Ooh, it worked. Great, huh? It is faster than the spinning the containers on the Google. It's all right. So you get your dummy project, my project, which is empty. This is Origin, again saying, so it has a bit different setup than the OpenShift Enterprise. The big difference is that you don't get all the predefined images loaded in. So you should load those things by yourself as you are starting to use them. That brings me that we will definitely need Shift Rankins. So everything is open source, like Red Hat already said. So all the images, all the components are available on the internet. You can search them up, apply them yourself. It just needs some additional effort, but the effort is really minimal. So, for example, if I want to have an image to spin up Jenkins, it's just going to the Git. Copy this line, so we will go here, OC, apply, I give it a namespace, OpenShift, I say it's a file, and tap, poof, create. Simple as that. And I have an image to spin my Jenkins instance on my OpenShift. So when we were thinking about the demo, what would be fun to show, I remember the one demo that I saw a year ago. So, and I was really could be related to this, and for me it was first time seeing this blowing mind blowing. So, how many of you are from operational department? How many of you have set up CI/CD pipeline? Cool. So this will be interesting for you. What if I tell you that we will be able to set up a full CI/CD pipeline containing systems like Git, Nexus repository, let's push SonarQube for code quality, pipeline and everything, and we spin that under 3 minutes.
Liberty Global?
Actually, I did it in Liberty Global. So we can have it later, a discussion. It is done in Liberty Global as well.
Just to deliver the hardware will take time.
Depending on which data center you are using, I have to say maybe on that first slide introduction, I'm working for Liberty Global, part of the...
If everything is settled?
So yes, we have been, in this phase, we have successfully closed the POC, which was proving that OpenShift as a platform will be able to replace traditional middleware in LG. And LG is a huge telecom with 13 different affiliates around Europe, so it's a huge effort. And yeah, this month we have got approval to go to the production. So we are closing our POC with the final reports, and we are preparing to spin a huge OpenShift cluster in 2 data centers, one in NL, other in the UK. So it will be something big, cool, and probably will not work immediately. So, CD demo. So I'm not going to steal some other people's work. So this is everything that we will be doing. It's already provided by OpenShift demos page. So I said Red Hat is investing a lot of effort in making this a success story. So if you go to the GitHub OpenShift demos, you will find all kinds of interesting demos, things that will get you interested to try it yourself. So this is one that I came across sometime. They are really, really tidy on how they do it. So depending on the version of OpenShift that you are, you can choose the branch. You get the whole instruction. So this will be the pipeline with Git, SonarQube, Nexus, Jenkins, all cool stuff. And we will be able to deploy a service on top. So I have downloaded this on my machine. So it should be somewhere. Java project, so what do I have here? It should be Shift, okay. Oof. Yes, we are here. One thing that you have most likely heard before is that the concept of infrastructure as a code. And probably you have heard about it and you have some ideas, but OpenShift is the first tool on which I have seen this working in production and in real life. So OpenShift and Red Hat and Kubernetes itself enforce really the scripting or the command line interfacing. So everything you do, you should script and implement with your scripts. No, there is no clicking on the consoles, configuring, then you have the mismatch between your environments and this kind of things. So no, it really enforces you to script everything and to run it with the scripts. Sometimes it's a pain in the to make all those scripts. There are tools, there are different ways where you could theoretically start building by clicking on the GUI, your application, and then when you are happy with the configuration, you can export that configuration, you keep it in your source repository, and you use it to replicate your application on the next environment. So how we can do it is not only that you open a black screen and start typing your YAML, but Yes, it should be, everything that you do should be scripted and should be kept in your Git repository. So this is a script that will help us to perform magic. So let's do it. So it even has a help. So it says if I want to do this, I have to call it, I say deploy, deploy. And because I'm with an admin, user, hello, what options I have to give a project suffix. Based on that, he will create some namespaces. Let's get a kiss. Kiss is a nice name. And we will not persist any data, it's only demo. Everything in place, check. It does some magic. Poof, successful. Huh? Demo gods are good to us today. See, so we have now new projects appeared on our dashboard. If I go to one of the projects, magic is happening. So the components are loaded and starting, OpenShift has started to spin them. So if I just want to see here what was that, so he says some namespace have been created. You can credentials for my Jenkins. Role bindings here. Credentials for Jenkins Nexus. So I have a dev project which is a Kubernetes namespace. I have a stage one which I will use for testing. I want to have that isolation between development and test. I have some pipeline which I use for deploying my service. Cool stuff. So see, it is still running. So those with the blue circle are ready. So we are still waiting for SonarQube. Maybe while we are waiting, I can show you that it's not really magic. It's all power of scripting. So what we basically did is we did run one script.
What are the items that are running? These are containers? Or
They are all containers.
Pods.
They are containers inside the pods. So I load the Docker image, which will spin me a container. In my case, I always do one container per pod. There are use cases where we tend to split that, but then we want to use some additional tools. For example, Istio Service Mesh. If anyone is interested, we can talk later about it. But in the best practice, in most of the use cases, one container per one pod. Because I want to scale my containers by scaling pods, and that's enough. I don't know, if I put multiple containers in one pod, then I cannot scale them independently. I can only scale pod. So I don't know why I would have a real use case when those containers are basically one unit, and I will always scale them together. In that case, I will give multiple containers in one pod. If that is any clear. So as I said, there is no magic, it's all power of scripting. Kubernetes provides only two templates, deployment config and a service. OpenShift extend that to embrace the full infrastructure of the code principle, so you can script everything and the jobs as well. So in this case, I'm just handling some variables. After that, I have some component called build config, so it's an OpenShift one. Very similar to those. So this one will be load the Jenkins pipeline. So I will have a Jenkins pipeline that will build my application, test, code analyze, archive it, deploy.
Can you zoom it in a little bit?
What?
Can you zoom it in a little bit?
I will zoom later. So this is. I will have you the full overview of this one. So how I can zoom this?
Yeah.
Better?
Yep.
So it will deploy into the dev. Then I will have here a promote, even a manual step when someone needs to click after successful testing and development to promote it. So they're all cool stuff. Config map again. This one it's plugin because we don't want to run all software, so we are running the latest Jenkins with Blue Ocean thing. So even that is possible to run through those templates. Demo installer, now this is a job kind, so I can template a job. So template will be a placeholder for a traditional bash commands. So I'm running some OC commands which will load the Jenkins image. It has override, add some labels. If it's FRL, then it will load GOX one image. There is a GOX persistent one. So persistent means that it will store memory. FRL that it will lose memory. So when you destroy the container, it will lose all the data. For the evaluation purposes, demo purposes, it's more than fine. So it will sleep, give him some time. So you can do really scripting. So you can do the script separately and then package it into a template so that you are able to have everything in one place with a nice overview and you run it once. Oh, but yeah, someone needs to write those scripts. So it has even the curl commands, so I'm going to GOX, I'm going to sign up to an external JIT to load the project into my, so pure magic. So let's see if our environment is running. Yes, everything seems to be fine. Can I? Okay, is this better? So I have deployment config, so this is my pod. In this pod I have one container running with the images and configuration. One thing very cool OpenShift that provides, it gives me those routes that I already talked about. So I can now, with clicking the route, get into my components. See, this is a JIT repository. I don't know if you have ever seen the GOX. It's a JIT repository written in Go language. Cool stuff. If you want to have a GitHub-like thing on premise, works perfectly.
Is it better than GitLab?
It is much better. Free stuff is better than the expensive stuff. I'm always for the free stuff.
GitLab is free.
No, GitLab is enterprise one. You have to pay license for GitLab.
Yeah.
This one is free as a freebie, so it's much better. OpenShift also gives those components. This is a keynote thing, single sign-on, so you should be able to log in on your components like Jenkins with OpenShift credentials. But when you first time to run it, it takes some time to connect everything. Gods are good to us. So I have here CI/CD KISS, so it's already project pipeline that I showed, it's loaded. So I said open Blue Ocean plugin to have it so beautiful. And I can run it here, my pipeline. But we are not going to run it like this because OpenShift has a nice feature when you can run your pipelines and control them from the OpenShift. So we are going to do that.
To be clear, we are now looking at a Jenkins instance which is running as a pod, or inside a pod, in the thing you just created with the script.
Yes.
On this machine.
On this machine.
Yeah.
Cool stuff, huh? I didn't keep in my head immediately as well. Yes. Nexus, so we will need this thing as well to store our artifacts. So yes, I have logged in here previously, or at least the password is always the same. And SonarQube, cool tool for doing your code analysis. Cool stuff. So we have 1, 2, 3, 4 components in our CI/CD pipeline. And we have spinned them all under 5 minutes. Traditionally, this was a month project, to be honest. 6 months. That is the cool stuff. This is really power stuff, and you see that infrastructure as the code, cloud native, containers in action. When you see it, then maybe you can understand the beauty of it. Feel free to stop me at any point, ask questions. It's a free format presentation, as you can see, and I'm already sweating. So the hardest part has passed, so all our components are running. Cool. So we want to see, okay, catalog. Okay, now when I said, we will be running a service. So let's see here. I have it in GOG. So we will be deploying this Spring Shift task service, a magical service with lot of options. But it's developed in JBoss, where is JBoss ARP 70, I think. So I will need the image based on which I will build containers. So how OpenShift works, it has this source to image, the project they call it, which basically enables you to give your Git repository with your source code. And you have predefined, certified by Red Hat images for building different programming languages. So you say, this is my source code. It's built on this type of Java, on this, whatever, JavaScript, Go, and you choose that adequate image. It will combine those two together, and it will spin based on that container for you. Cool stuff. So you don't have to do your Docker files and creation. So it's full standard based, and you are sure that it will run based on the latest standards. To enable that, I have again to go and load an image. So it's an OpenShift. Yes, I did this before.
If the image doesn't exist, then you can create your own image and add it to the repo. So then you build your own image of JBoss to go add it to the repo, and then put your code in.
Image stream created, cool. We will be ready to deploy our application. So where are we? So that is the catalog, monitoring. It has all those events. You get the overview while it was spinning around. So I see all these events created, successful assigned, mounted, blah, blah, blah. Basically, okay, this is some interesting readiness probe, health check, liveness probe. So, like the guys already touched this, Kubernetes works on the way that you say, this is my service, and I want to have this many replicas of this service. So I suggest that, and Kubernetes will look at he will spin, let's say, 3 different services, and he will check the health of them. So you have to enable in your service some kind of URL health checks, health probes. By calling that probe, the service will give some results, say, hey, I'm healthy or I'm not healthy. And there are all kinds of probes that you can create. Some of the health. So one thing is that is spinning and healthy. Other one is that is spinning healthy and it's able to operate. So for example, if your service needs to connect to a database, it's not enough that he is running and healthy if he doesn't have connection to the database. So you can fine grade those probes so that you are Kubernetes and OpenShift will make sure that they will check all those things before they route any traffic to your service. So they will spin your pod, they will create your container in it, and then they will wait until they push the traffic to your container until all probes are verified as healthy and okay. Cool stuff. So we will see that also later in our demo. Storage, okay, this is all my local thing. Resources, so you have all kinds of resources that you can configure, secrets. So if I need some username and password to access the Git, Gogs, whatever, I create a secret which can be used to access, share. But the most important components are here: the build, the creating image stream pipeline.
which we will use. So this is the Jenkins pipeline, which is created on the Jenkins. So I have shown you already, and I can run it from here. But I also see it here in my OpenShift console, so it's better overview, less clicks going, and I can start it now here.
Is this something OpenShift finds out by himself, or do you need to tell OpenShift this is where I have a Jenkins build?
No, it finds out by himself. If he, okay, you have to tell him where is your Jenkins.
Yeah, okay, yeah.
If he knows where is the Jenkins, he will be able to obtain the pipelines. Pipeline can be directly pushed to Jenkins and used by OpenShift, but it can also, you can deploy it with your source code, with the template of your application to OpenShift, and then OpenShift will push it to Jenkins. It works both ways.
So are we using any kind of plugin in OpenShift so that OpenShift knows?
No.
No? So how does it know what action?
You saw that I told in the beginning, I have an empty catalog.
Yeah.
So in an enterprise grade, you get the full catalog with all these kind of images. I had to load a Jenkins a feral image, which is a script that tells how to run Jenkins on OpenShift. So that script will pull Jenkins image original from the Docker hub, and then add the configuration, add all things that it needed for OpenShift to run, and it will spin you a Jenkins. So you don't have to know anything. It's all covered by just for you to use the recommended image from Red. So that's all. Don't experiment with your images if you don't know what you are doing. If you know what you are doing, good luck. But yeah, that's the power of the images. The same thing I did it now with loading the image for JBoss service. So it will have all that magic scripted inside to enable my source code, which is not aware of OpenShift at all. It will combine that code with that image and will spin a container that will work on OpenShift.
I missed the part where you imported the source code. Was that part of which?
So I start the build.
Yeah.
We have a log. Oh, it was too big. So start your traditional way. So I think the first step, full log. Full step would be to go to the GOX, to repository, and clone your code. So that's why I didn't. I just gave them in the template, I gave them the location of my source code. Mm-hmm. So this is the URL of the Git repository. This is the name of the service. Oh man, we are already too far in the log.
May I ask one not really fair question?
Just here. See, this was the part of the script that I loaded.
Yeah.
So I gave him the Git repository, OpenShift task, and he will load that, and then he will just connect to the Git, clone it, start building it. So is Sarajevo losing the match?
No, it's 1-0.
For Sarajevo?
Yes. I don't, Adnan, if I may ask a question. So you could actually script all this in a Linux machine.
You can script this also in your notebook.
Yeah, what is the difference between the script running on a Linux machine, let's say, who installs all this and configures it for manually?
You cannot script everything on your Linux machine. First of all. So your Linux machine is not a Docker container, it's not a Kubernetes, it will not recognize deployment config component, it will not recognize service, it will not recognize build config, those components. You can do that job part that is your bash script, and that becomes only one of the components that is needed to spin all the environment. You cannot do everything with Linux.
I mean without containers, without that, just Linux, and you install all these components directly on Linux with a script. A big bash script.
Cool stuff, man. Glad that you asked.
No, what's the difference? I mean, what
the difference is the time. The things that you are mentioning were 70 years ago.
Well, but if we come to the present, you can get just Docker images. You can run a few Docker images and you can get the same infrastructure in
this you can also.
Okay, but then you will have problem of scaling out Docker images. Then we are going to the concept of Docker Swarm, which is not the Kubernetes. It gives you the networking between multiple Dockers. But then if you want to scale out, and it is easy when we are speaking about one service. Imagine I have to create something for thousands of services. And thousands of services, if I want to have them high available to different zone load balancers, then multiply by at least 3.
Where's the role of Redshift in this, how it makes this scale, how this happens? Because so far it looks like...
we just deployed it. We have to deploy it and then we will scale it up, kill it.
So but it looks like I can script, this is what actually I think he was mentioning. I can script a few Docker images being set up and I can run this on multiple services and servers and that's it.
Yes.
So what is the added benefit of Redshift? I see a lot, but it's more...
Non-enterprise would allow you to do that. With due respect to all your skills level, I want to have a secure company verifying those images, verifying those containers, have a support on it, and I don't get that from you.
This is the same because you use a lot of open source stuff.
For all open source here, Red Hat gives the approval, gives the certification for it, gives an enterprise support for it, guarantee. What?
It's not for free.
It's not for free.
Yeah.
If you can do that for free, then join the Netflix. Maybe
the
there are also
open
cool guys doing that.
just a marketing game.
It's about the skills levels that you have in house. So if you are able to pay developers a couple of hundred of Ks, you get the astronomers in your team, like some company in Silicon Valley, fine, you don't need, they are not using this. They are developing their self components. If you have developers like we are used to develop, then you want to have some security, you want to have some best practices, you want to have some framework around it. So you pay for a platform, but then you get a bit cheaper developers, or you pay for your developers and then they do everything for free.
Yeah. I just had, my question was a little bit more on the resource management side, but also had this question, they also combined.
So is that OpenShift a deployment and configuration platform?
It's a platform as a service, which means it's a full platform for building, like they say. Other platforms, I would say, for building applications. It's a platform for building applications. What you now consider an application, that is really debatable. It can be a collection of multiple independent services. We are planning to use it for microservices. You can spin only one service like we are doing here, or you can spin some big applications on it. So imagine
if we have a huge organization and we have hundreds of computers or thousands, and we want to spin up multiple instances. How is the resource management? Is it I need to specify which exact nodes this services needs to run, or it has automatic resource management?
Okay, so first you need to enable your data center to install. So you will either go with the VM setup, so you virtualize your data, or OpenStack, Red Hat. So you virtualize your data centers. On top of that virtualization, you install OpenShift, which has cluster of masters, 3 masters, let's say, which needs to have that quorum. It has to be an equal number. And then you create a pool of your data center. So on each node, it needs to be installed an agent for OpenShift. So he knows that this node is available for usage.
So when you move to OpenShift, you forget about your nodes. You don't care which node your application is running anymore.
Yeah, I'm thinking in more abstract resource. I have resources, and how the resources.
You just virtualize them.
How it decides on which, where exactly it should
Depending
run, so
on
the resources are uniformly distributed, not like overloaded somewhere. Or
so by
I don't have to manually specify exactly where this needs to run.
So you can do that. So by default, it will look for the node which is the best resource-wise. That's the default behavior. So when you ask to spin up a pod, it will look for the node which best fits.
Is it based on
on the current load, on
the node, or how it is loaded? Is it
depending on the node,
or
yeah, how resource utilized the node is.
So it does some resource needs not real time.
It looks at the level of the resource usage. And you can also actually specify which node you want to deploy if you want to do that.
this is the, by default, you don't need to specify anything. So I didn't specify anything, and he was running all those components on the hardware that's available on my machine. But you can do specification if you have different type of nodes in your landscape. So you have some servers that have more processor than memory and vice versa. You want to use them smart. So you don't want to push and dumbly assign your service to any of the components. Okay, if you want the simplicity like we are wanting now, it can be done. Then OpenShift or Kubernetes exactly will do its magic and allocate your resources. But I can force my service to find a specific type of hardware if needed. And then also the databases, you can enable them through the virtualization as well, and he will pull it from the pool. So our service is deployed. So how cool is this? So let's see what happened.
I have a question about that pipeline.
Okay.
Yeah, so this is all happening inside Jenkins, right?
No, Jenkins is orchestrating this, and this is all happening in different components. For example, okay, build up, it was handled by Jenkins. So then he was calling the Maven plugins to run the JUnit test, so this is also in Jenkins. Code analysis was pushed to the SonarQube. So I have it here. So this application, if I refresh it, I should see the project. Oof, see, passed. Beautiful, we are building clean code. So this was, Jenkins has delegate SonarQube to do the source code analysis. When the testing and source code analysis passed successfully, then he goes for the second step. Let's see, what was the second step?
Yeah, but what I mean is this whole pipeline is the Jenkins DSL.
Yes, exactly.
Okay.
You can see it, yeah?
Yeah, you can look at the config for the pipeline.
Edit. Oh yeah.
So how do you provide the input that is asked for?
You can look at the action.
Just a second, how do I get those? See, here, here's the Jenkins 5. So I have even the definition. There's the manual build, I clicked on the button, and then you have all that pipeline that we previously loaded. So I can even tweak it here. It's not smart to do, you always want to keep it in your scripts. But yes, it's fully Jenkins. There is no additional magic or overload on it. So if you know how to configure it in Jenkins, it will work here as well.
What input did you need to provide?
For what?
It said input required.
Because it was a clean build before anything was there. So now the pipeline runs, and now it has some.
Now it means the yellow thing.
Yeah.
If you want to deploy it to the staging environment, you need to push a button.
Okay, sorry. Yes, we will come to that. Sorry. So we did the code analysis. We have archived our app in the Nexus. Create image, build, it has created, build it. So these are the creating and building, it's our OpenShift components. Just a second. And as deployed, it created a dev and deployed to dev. So if I go to the namespace called dev, see, it was empty before, and now I have my service running, just to show that the stage is still empty. So if I go back to dev, I have my service running, and I can click on the service, and this is this magical service which generates some logs, warnings. It will give me name of the pod on which it's running. Cool stuff. So if I want to test logger, this is cool. If I want to test my monitoring Prometheus, I can generate load. It will give me some metrics. But we are really interested in the danger zone. Huh? So I can handle here toggle between those health probes that I mentioned before. So because that is generated from my service, I can manipulate them. So on the click, he will generate a health probe saying I'm not healthy, and that means that
Kubernetes which wants to keep the state of healthy pods, it will immediately kill that one and spin a healthy one. That is that cattle pets. So we are not petting them, we are killing them and spinning new one. So we say kill instance, and if I do a refresh, oh, terrible experience. Terrible. Service is down.
It's not up yet.
It's not up yet, so I have to wait now until he is back. So I will
if you run the pipeline, can you trace in OpenShift also logging to see what is happening?
Of course, of course. Okay, it will not trace me in OpenShift. It will, you saw it already, I think. It will forward me, so where's my builds? So I have here view logs, but it will forward me to the Jenkins. Because basically Jenkins is the owner of this. This is only for convenience that you can run it from one place, but real magic happens on Jenkins, so he pushes you to Jenkins and you see the full pipeline. So that yellow button we will click, but that is the manual. So promote to stage, and I have to promote or abort. After we test it and verify that it's working correctly. So where is our service dev? If I reload it, F5, so it's back. I have the new name of the pod, so this was a terrible user experience. We don't want to happen this. So we want to ensure that if I'm going to scale it up, just on clicking on the button, I'm spinning 3 of them. So this is the beauty of those pods. I have a container in one pod, just click, just spin them more. I can make this persistent by updating my YAML file and saying that I want the replicas to be always 3. That would be the best practice, but for the demo purposes, I can click on the screen and it will spin pods, and it does pretty fast. So even if we are speaking here, he should start running them. Not that fast.
So that also updates the gem file?
No, it will not update the gem file. In this case. Okay, it will, but it will not in my source repository, which I use to start it up. So if I go here, edit, I would have to go, I think, to the deployments. Let's keep that for later. Yeah, it will update to the current state in my YAML file, but then I have to export it and import it in my source code and then make it persistent, because so if I go to my service, say, how are you? He's good. Kill an instance. And I do a refresh. Remember the name here. So if it's good, it will change the name. Poof, new name. Wow, it works. Thank you. Magic happening. No one noticed. Yes. So let's do one more for fun. See, and my Black Friday sale is safe, so it did kill them because he noticed they are unhealthy. I still have one running. I'm able to give that user experience for user. So the scaling, automation, auto-healing, all the buzzwords in play.
Okay.
Yes, we can do it in Linux.
No, I'm not going special. But you are talking about healing the pods, and they are starting out healing themselves. What happens with the data, with the sessions? In between?
You design your system in a way that it's unaware of sessions and data. And then you protect your data to be outside of your service. The concept of microservices, so you should read my architecture.
So basically, it's running, let's say I start a sales journey. It's a web application, I want to buy something, it's running in the pod. So I fill 10 forms, I want to submit everything, and it just breaks. I mean, the pod is killed. So I've lost all the data soon, because new one which starts, I need to repeat everything.
Your data will not be stored in a container, first of all. So you will spin, your service will be in the container, which will proxy your data connect. So your database, best practices should be in a separate cluster, high available, depending what type of database you are using. So your data will become persistent. Then we will create storage, I don't have it here.
No, I understand.
But I'm able to
What you
do
mean.
so. So your service,
Before
if you develop your service that it's stateful, it's not a smart way to do it in the microservices. So microservices preaching about unstateful services. So it should do one thing and quickly. So the concept that you are trying to impose to this platform is it's I wouldn't say wrong, but it needs to be adapted for the cloud native infrastructure, for microservices, for containerization, for.
Okay. So it's okay.
I'm coming from the same world, so don't get me wrong.
You can store a session in the database.
Yeah.
Store a session in the database.
But it will be in the database.
Yeah.
So we took too many time, and my pipeline expired.
You're in the wrong.
I'm in the wrong CI/CD. So bills. So you guys are following, so that's great. So it was 15 minutes, and I spoke too much. In this case, if I would click that.
I warned you, eh?
Yeah, that's right. I had it here already. So I would here click accept, and he will deploy the same image in a different namespace.
And you can also see that in Blue Ocean now.
What?
You can see it in Blue Ocean now that it had run as well.
Yes, of course. Where's my Blue Ocean?
So in practice, every commit to the repository will trigger this pipeline and then create
Configurable.
dev environment.
Configurable. So that is with the webhooks. I don't prefer webhooks, to be honest. Depends. It can be done.
Yeah. But I mean,
In this
it
case,
creates a new development environment or pod
Yes.
in this case
Yes.
every time it's triggered.
No, the pod is already running.
Yeah, but it says create dev.
It will, okay, the badly naming, we can tweak it. It basically will see if there is already one existing from the same name, it will clean it up to have it.
So there's always one dev pod. It will be
Okay,
overwritten.
that is based on the namespace. So as he said, you have by default one big namespace on your cluster. But if you want to isolate projects between itself, then you use the namespaces. Namespace will be a logical isolation between you. So I call one namespace development, other one. So I can have for one project one development, for other project different development, and in one development namespace I will most likely have multiple services. If I spin a new, now what you are saying probably, if I start a new, again the pipeline, it will go through the same build process and then it will overrun my current pod. Because it doesn't have to be that, but I'm lazy and I put it to deploy always the latest image. And I have already latest deployed, so next latest when it comes, it will overrun. For the production readiness things, we have created smart ways with versioning, so it will not override. You will have the different versions of the images, same service with different versions, so you can go back, you can go, so flexibility. It's nothing related really to OpenShift, it's how you structure your Jenkins, so it's traditional Jenkins pipeline and how you handle if you are reading the version from your POM file or what you do, it's up to you.
So can you give the right to promote to stage and to prod to a different group or different users?
Yes, first of all, I will bound users per namespace. So, development team will have only access to development namespace, and that is their play area. Okay, this is also a very hard thing that we have, because it embraces this DevOps concept, and it assumes that you already have accepted DevOps, so you don't have different teams for developing, promoting, deploying this. But in the real world, we have that. So right, because in that case, we have these different namespaces, and the CI/CD is a generic one. That's for the release management team. Though they are not developing, you send them an email requesting, hey guys, could you please deploy this, and they then click and deploy. So to keep the traditional way, so developers will only see the access to the development. There will be users which we add, even in that script when I was creating. So at this point here somewhere, see, role added to the service account Jenkins. So in this case, he's allowing Jenkins to deploy into the dev and into the stage environment, because the Jenkins is originally located in the CI/CD namespace. So I'm bounding him here. Namespaces are totally isolated, so you can give those permissions. Then you're careful. You isolate your developers, and then for the release management team who needs to orchestrate, then you give some rights. It's better to keep it on the system users. So I give right to a Jenkins, not specific to Adnan, which is working for release management. All ways are possible. It's just your imagination. And that's also the hard part of all this. Everything seems to be doable. So we are mostly coming from the traditional setups where we would buy a big box of Oracle, TIBCO, or any other, and then you have all these cool features in that box, but only one, and you don't mix them, you don't think about them, they work nicely together, and you just use them. And we were a bit bored with this, so we wanted, let's give us flexibility. I want to change, I want to adapt, and then be careful what you wish for. Because in this case, you have so many options, so technology is constantly changing, improving, and everything. So, for example, we started 6 months ago with this POC, proof of concept for replacing the middleware. We have nailed down a reference architecture which was combined of different open source tooling that we wanted to see. During these 6 months, new technology popped up. So you're not, even in the 6 months time, you are not able to nail down architecture. And that is different from what we have been used to. So WebLogic is almost the same for last 5-6 years. Here, for example, this Istio service mesh came into the picture. It's a cool thing. It didn't exist 6 months ago. But now it exists, and we want to incorporate it. And you get that flexibility, but it's not easy. So you have to use your brain more. You have to try and fail and learn on your failure. And then they were also saying, for me, are you prepared for the presentation? No, I'm prepared for failure. And that is really the mindset that you need to have if you are going into this new setup of cloud native. You have to embrace the failure. You have to be prepared, because things are failing. They will fail all the time.
That's why you need to click promote now.
Click shutdown.
Input required. Poof. It does something. Success here. Wow. Which means that now in the stage environment, which was previously empty, I should see my service. See, it's running. And it will have a slightly different URL from the dev one. So they are distinctive. Even if this is the same image, I can have it called from different applications. So I get a real stage endpoint. It's still running. But this one has it was dev kiss in the URL. This one is stage kiss. Give him some time to run and see. Beautiful. So I have in 2 different namespaces where the 2 different teams, so my development can continue enhancing their service, breaking it, while the testing team use this stable version in the stage environment to perform the test. And I can extend this to production as well. I can extend it to multiple namespaces. I have different test teams, or I can have only one and do everything in production. So it's all up to you.
Cool.
Any other questions? Otherwise, I'm done. Thank you.
Thanks, Adnan.
Nice talk.
I've got a couple of things I want to say and ask. First of all, who learned something tonight? Yeah? Oh, that's very good. We might or might not send out a survey, especially to the externals to Devoteam. Also to ask you if you're interested in a follow-up. This is the one-on-one session. We might be doing a more in-depth version of this. Next to that, we have not two competitors, but we've got Lex. And you asked for a brief moment of our time to introduce yourself, because there's an event coming up that might be of interest to some of us here. So,
hi, I'm Lex with Proteo. We are a company here in Den Haag, and we do OpenShift as a service. So if you not only the list that you saw there, but also at our site, you can get your OpenShift trial. You can try it. You can buy OpenShift running on bare metal, and we do OpenShift managed services. Just wanted you to know that there is OpenShift service providers around, also close by. We have an event with, oh sorry, camera. We are organizing an event for government agencies who are transferring to OpenShift soon. If you give me your business card, then I can get you an invitation for that. And that's in the Rode Olifant in Den Haag. That's all. So find me if you are interested in using OpenShift and you don't want to set it up yourself.
Excellent. But this is The Hague, and we've got a not competitor, but someone or some company that might be a nice addition to Devoteam as well, which is even closer by. It's on the 6th floor, at the end of the hallway. And I'm sorry, I didn't catch your name.
No, Marco.
Marco, could you introduce the concept that you're trying to build? Or
Okay, I'm Marco de Kapers. I work for Hot Potatoes. We also provide OpenShift appliances. Feel free to contact if you want to know.
But on a much better platform.
Much bigger.
Okay, then for the Devoteam people, open air, 3 hours training on for this KISS. That's what you can book. Lastly, for all the Devoteam people, did you already sign up for the summer event?
Yep.
Who didn't sign up for the summer event? Why not? Please do so as soon as possible, because we still need to make the booking at this venue. And lastly, I was not joking about the stickers, so feel free to get some when you get out. Yes?
Nee,
dat verrast me. Okay. Gopal, Stephan, Adnan, you can take the sticker. Really?
The inches, what do you have to do?
Oh, dat kan. Ja, dit jaar weer.
Ja, dat is helemaal. Ja, dat zijn maandag.